Now we're going to look at the method of raw construction. We go back to this amazing form of a power series that a function f can be written as such. And let's take a look at the function f of x equals the sine of x. Now if I'm going to raw construct this, that means I need to find the particular elements of this particular form of a series. So let's get right to work. I'm going to need f of 0. So f of 0 is simply the sine of 0. And the sine of 0, as you know, is 0. I will also need f prime of 0. So the derivative of f is going to be cosine, and the cosine of 0 equals 1. Great. I'll take a look as I raw construct the second derivative at 0 of our function, and that's going to be negative sine of 0, which is also 0. And then I'll look at the third derivative, and that's going to come out to be negative cosine of 0, which is negative 1. Now, I hope you see that if I took the fourth derivative, I'm back to here, and then the fifth, and then the sixth, and then the seventh, and it keeps repeating in this pattern. So I'm going to come back now and say, well, the sine of x can be written as f of 0, which is 0, plus the coefficient f prime of 0, which is 1, times our x, plus the second derivative, 0, times x squared over 2 factorial. Now I'm going to do the next one, plus it would be negative 1 x to the power of 3 over 3 factorial, plus dot dot dot. So that looks very messy. So let's do some tweaking here. I'm not going to write the 0 term, so the first term of sine of x is x. The next one is going to be minus x to the power of 3 over 3 factorial. Now, can you tell me, or think in your head, what the next term in this series is going to be, the next non-zero term in this series? If you said plus x to the 5th over 5 factorial, then you're seeing the pattern, because again, this would be the 4th, this would be the 5th, and then the next one would be minus x to the 7th over 7 factorial, plus dot dot dot. Now think about this. Can you tell me the nth term of this power series? Well, we see that it's strictly alternating, so negative 1 to the n, and then it's going to be x to some power over that same power factorial, and these are odd, so let's take a look at 2n plus 1 power over 2n plus 1 factorial plus dot dot dot. And that's amazing if you think about it. The sine of x can be written as a sum of polynomial functions to actually make the sine of x. And if I summarize here now, this is going to be the sum. Let's say n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And just like in the other section, we always have to find an interval of convergence. So how would you find the interval of convergence here? It's not geometric. If you're thinking ratio test, then I'm very happy. You can't see it, but I'm smiling. Wait, here you go. Here's my smile. Good. We would do the ratio test, and it turns out by the ratio test that the interval of convergence is true for all values of x. Wow. Awesome. Now let's use this raw construction method to come up with a power series for the transcendental function e to the x. So we're going to need g at 0, and we need as many of these as we can find to create a pattern. So g of 0 is going to be e to the 0, which is simply 1. G prime of 0 is also e to the 0, which is 1. The second derivative at 0, behold, is also 1. You can see quickly that all the derivatives of every order at 0 will equal 1. So our e to the x is going to be f of 0, or sorry, in this case g of 0, 1, plus 1 times x, plus 1 times x squared over 2 factorial, plus 1 times x cubed over 3 factorial, plus dot dot dot, plus the nth one is x to the n over n factorial. This does not alternate. And I'm going to summarize now. So e to the x is the sum from n equals 0 to infinity, simply x to the n over n factorial, with an interval of convergence via the ratio test. That's not really dot dot dot, it's more of an arrow here, more of an arrow of sorts. So the interval of convergence is going to be true again for all real values of x. Interval of convergence, interval of convergence. Cool. You're going to memorize these. Eventually you're going to have to memorize these to do some other techniques. And just when you thought it couldn't get more exciting, we look at this function. Again, f of x equals 1 over 1 minus x. We've seen this. This is the sum of a geometric. But let's suppose we did not recognize this as the sum of a geometric, and we went through the process of raw construction. I'm going to write this as 1 minus x quantity to the negative 1 power. That's going to help us when we do our derivatives. And so f of x equals 1 minus x to the negative 1 power. And then f at 0 is going to be 1 minus 0 to the negative 1 power, which is simply 1. And let's then do f prime of x. F prime of x, well, let's do this. The negative 1 comes down. Then we have quantity 1 minus x to the negative 2 power. But then by the chain rule times the derivative of stuff, this becomes positive. And then f prime of 0 comes out to be 1 to the negative 2 power, which is still 1. Careful though, they're not all going to be 1. Let's take a look at the second derivative. So again, the negative 2 comes down. 1 minus x to the negative 3 times negative 1 for chain rule becomes a positive again. F double prime at 0 comes out to be 2 times 1, or simply 2. I would definitely like to do at least one more. So I'll do the third derivative. This is going to become 6, 1 minus x to the negative 4 power. Whoa, that is a negative 4. Not a negative blah, a negative 4. So now f triple prime at 0 is going to be 6. And I can't control myself, I want to do one more. The fourth. Once you get past 3, it's okay to write as 4. Some might recognize this as a function to the 4th power, but when written along with the others, it is recognized to be derivatives. So we have 24, 1 minus x to the negative 5. The 4th derivative at 0 comes out to be 24. Okay, so now let's plug this in up here. So coefficient, first term, is f of 0 is 1, plus 1 times x, plus 2 x to the power of 2, but then it's over 2 factorial, plus 6 x to the power of 3 over 3 factorial, plus 24 x to the 4th over 4 factorial, plus dot dot dot. Do you see this? Isn't that amazing? We have 1 plus x, and then the 2 is going to cancel out with 2 factorial to be just plus x squared. The 3 factorial is equal to 6, so that cancels out. X cubed. Same with the 24 and 4 factorial, which is exactly what we found when we saw it as a sum of a geometric. 0 to infinity x to the power of n, with an interval of convergence as we found earlier. Awesome.